Welcome to Machine Learning Lesson 4.5. In this video, we're going to go through an example of using multilinear regression. And one of the things you're going to find is that it's just an extension of the linear regression object. We're going to kind of go through some things over again just to demonstrate the development cycle. So let's get to it. So the first thing we have here is that we have to load up the libraries. So we have pandas, we got matplot, and we have our scikit-learn library. Just to reiterate, notice we're bringing in the linear regression object, which is the same object we use for just a regular univariate linear regression model. Again, univariate just means we used one variable, as compared to what we're going to do now, which is multilinear regression or multivariate. We're going to use a couple of features to try to predict our target. So let's run this. And you've seen this data set before already. This comes out. Okay, so this is our data set that has miles per gallons, displacement, horsepower, a bunch of things that can help us to determine how many miles per gallon a car gets. And just as review, we typically will do a describe or something to kind of investigate a little bit of our data. And we see here, we got a bunch of statistical information, which you're more than welcome to look a little further into it. I'm going to continue going on. Another thing that is useful is that we see that there's some columns we don't want. So let's eliminate that. So let's say df.drop of labels, and let's drop the origin. Let's drop the model, lowercase, model year, and it doesn't show up on the describe. That's because it's not numerical information. Let's drop the car name as well. And almost forgot. You have to put axis equals 1 to let pandas know that these labels have to do with columns and not some kind of an index. All right, so let's run this, make sure everything's cool. Okay, and just to kind of see that we have eliminated those columns, let's do a data.correlation, cores, just to kind of see relationship between the different features. And in previous videos, this part I'm not going to go further into it. This is where you would be analyzing your features and figuring out which ones are the best ones to use. Now for us, what we're going to use horsepower and weight, because they have very strong correlations. Even though they're negative, they're still strong. So you might also say, well, why aren't you using displacement? Displacement has a higher number than horsepower. That's because when we looked at displacement and weight, we saw that both of these have a high correlation together. So if you include one, it's a pretty good indicator of the other one as well. So there's no need to include them both. It'll be redundant. And you're going to see that later on towards the end of the video when we start adding extra features. You'll see that the addition of displacement as a feature to predict miles per gallon won't add anything to our model. But again, so we're going to continue on. So now that we've kind of analyzed our data, we've selected our features, which would be horsepower and weight, we actually have to go through our train split test part, which is to actually separate the data in order to prepare it for the machine learning model. So the first thing, which I find very nice to do, let's create a variable. I'm all over the place on that one. Let's create a variable, desired features, and let's just make this into a list. So what are our desired features? We want horsepower and we want weight. So it's just a list of strings. Again, it's going to make more sense later on when we have to reuse the idea of what were our desired features. So now that we've done that, I'm going to use a different word, which I briefly introduced in the linear regression video, which is our target. Our target is what we want, and what we want to get is our miles per gallon. And our features which is the things we're looking to predict, will be the ones that come from this array, the desired features. So the cool thing here is, let's say you decide to add another feature. You can simply add it to the list here, and you don't have to change your code down here. And let's just run this, make sure everything's okay, even though it's not going to do anything. Good. So we've separated our data. We are now ready to do our train test split. And what does our train test split want? First thing it wants is our features. Then it wants our target. Then it wants our training size, our test size. So let's put test size of 20%, 0.2. And if you recall, there was something called random state that we can add to our train test split, which will make it convenient so that you at home can get the same results that I get. Again, it's not a seed. It's not a random seed like you might see in C++ or some other languages. It's just an ID. So that the same data that I select for this video will be the same data that you select if you use random state. And let's just assign this to a variable, and let's display that variable, and let's review a little bit of what we get. So the first thing you'll notice that we do get a list that has 4 things. So the horsepower for 313 rows, and then horsepower again for 79. So here's your 80-20 split on horsepower for training and for testing. Now, if we go to our next one, we'll see that this now becomes our miles per gallon training and test as well. So what we're going to do here is that instead of doing a variable d, which is a list, again, Python has this nice feature. Let's say features train, and then features test. All right. So instead of assigning it to a variable that is a list, we can assign it to 4 variables instantaneously. I think that's pretty cool of Python as a language to provide. And then the next step would be target train and target test. And just to prove to you that we have successfully split off the information, let's go ahead and just print out features train. And you can see here, here's the data for the features being trained. So now we're ready for the next part, which is the actual machine learning. Again, up until now, all we've been doing is kind of just manipulating the data, aggregating the data, preparing the data for machine learning. Okay, so we mentioned that multilinear regression is just an extension of linear regression, so we still have to create our linear regression object. And here's the beauty of it. If you recall it from the regular linear regression, multilinear regression, you don't do anything different. It's an LR, whatever you named your object, fit, and what are you going to pass it? You're going to pass it the features that you selected for training and the target that you selected for training. All right, and there you go. Okay. Again, you don't get much more out of this other than just seeing that there wasn't any errors. The key comes in the next part, which is, okay, now that we've kind of trained our model, let's evaluate it. And we're going to evaluate using the testing data. So we'll say features test and target test. And let's see how well our model did. Okay, not bad, 76. If you recall from the linear regression example in the previous video series, we had a 25% accuracy, very low, very unreliable as a model. 76, definitely a lot better. All right, so now that we have that, we kind of have to go through and let's see what we can do with it. So let's create a variable called test, which will be a sample of our data. let's also, actually, let's just print it out at this point. Just kind of prove to you what test does. Okay, so there's test. Again, it's a random sample from our data. And if we run it again, we'll get another one. Our main thing here is that we want to be able to visualize our mileage, actually our horsepower, what are our features? Our horsepower, our weight. So obviously we're not getting that from this. So let's do this. Let's go ahead and select those columns. Oops, I just realized. Also, let me do it a little bit differently. I already have this saved up. Again, just so we're not wasting time watching you type, watching me type. Let's bring that over here. Okay, and let me just review what I've done in terms of code. So here we have our sample. We've selected our test features, and we've now gone through and used our model to predict the miles per gallon based off the sample that we get, and now we're going to be able to compare. So let's see how we did here. Oops. Oh, because it's the desired features. That's what happens when you copy and paste from different areas. Okay, so let's see what we got here. So our sample predicted, well, our sample had a 13 miles per gallon. Our linear regression model, multilinear regression model, predicted 15 miles per gallon. That's pretty close. Let's run it again. We got 17 and 21, not too bad. 18 and 19. So you can see here, having that 76% makes a big difference. We're not so far off. Now we did get a couple. I mean, a mile. Actually, this is closer to 2 miles off per gallon. This is 3 miles off. 3.5. So we're kind of going in the wrong direction. 4. Wow. Can we get it back down? All right. So this is also 4. So again, not great. Again, 76% is not something to be happy with, but definitely is a better fit for our data than what we have seen in the previous example. So let's go back to our presentation. So in this video, we saw that linear regression, multilinear regression, is just an extension of the linear regression object in that we simply just provide more features to fit our model. The development cycle, as you'll see, it's the same thing. Look at your data, prepare your data, separate your data, train your model, evaluate your model, and then finally use your model. Try it out, see if it works. So hopefully you've enjoyed doing this, regression model. This is your first machine learning algorithm, which you can use to predict whatever you want. Baseball statistics, forecast of the weather, will I pass at the end of the school year? Again, these are all things that can be used with linear regression. Enjoy.